Sixth grade, we're starting chapter 4 today. Chapter 4 is about fractions. We're going to start talking about what a fraction is. Okay? A fraction is a number of parts out of the total. It's a number of pieces out of the whole. Okay? So, the whole, if you have less than one, or if you have something that's cut up into parts or pieces, like a whole pizza cut up into slices, then you have a fraction. The top number in a fraction is the number of parts, either the number of parts that you have, or maybe the number of parts that are missing out of the whole. It's the subject of whatever you're talking about. And the bottom number is called the denominator. The bottom number will tell you both how many pieces would be in the total, in the whole, or how many, or what size the pieces are in. Okay? The denominator can tell you how big the pieces are. So, if you have a large pizza, and it's cut into thirds, are those big pieces or small pieces? Those are big pieces, right? You'd have a slice of pizza that's like this big, right? What are most pizzas cut into? Yeah. Eighths, maybe sixths. Usually not fourths, unless you have like one of those little party pizzas. Those might be cut into fourths. Okay? But most pizzas are cut into sixths or eighths. They're not cut into sixteenths or eighteenths. Why not? Right! Those would be really small pieces. So, those are, we're talking about the denominators, right? The denominator can tell you how many pieces are in the whole and the size of the pieces. They give you an idea of the size of the pieces. Okay? Now, let's say that we're talking about this little pizza drawing. Okay? There are 3 out of 4 pieces left. So 3/4 of the pizza is left. Okay? Now, if you're like my family, I have 3 older brothers and an older sister and a younger sister. So there were 6 of us. And if there were 3/4 of the pizza left after we all had a slice or two, Mom would do what? No, she wouldn't eat it all. She'd let us have some more, but instead of having 3 pieces left, she would cut them into smaller pieces. Right. Yep, so we could each have a little bit more. Yeah. Now, by doing that, we still had the same amount of pizza, but she cut the pieces in half and made the slices into, instead of fourths, they're now into what? No. Eighths. And how many pieces are left? Instead of 3, there are 6. Right. 6/8 is equal to 3/4. What is equal about them? What is equal about 3/4 and 6/8? What is it that's equal? Ooh, Max? Yeah, what is it about 3/4 and 6/8 that's equal?
If you divide 6/8 by 2.
Okay. But I'm thinking about the pizza.
Oh.
What is it about 6/8 and 3/4 that's equal?
The same pizza, except
the same pizza. Yeah, we didn't change pizzas. Alex?
They're like, you have to divide, so if you divide 6 and 8 both by 2, you get 3/4, because they're both even and they can get divided until they're odd, so you can't divide them anymore.
Okay, but I'm still thinking about the pizza. So what is it that's equal about the pizza? How much is left? Exactly. We still have the same amount left, don't we? 6/8. If we have 3/4 of the pizza left, okay, you're not concentrating. That's enough. Okay? Concentrate on what's going on here. If you have 3/4 of the pizza left, and then you cut it in half, so you have 6/8 of the pizza left. What is it that's the same in those fractions?
Like if you add up 4 plus 4 is 8 and then 3 plus 3 is 6. That's kind of...
What did you just say? Who was it that answered my question before I got distracted?
No one.
Oh, Emily, what did you just say? Right, the amount of pizza left is equal, isn't it? The amount of pizza that's left is equal. What is it that's different about 3/4 and 6/8?
It's simplified, like into a little.
Simplified. But I'm talking about the pizza. What is it that is different in terms of the pizza?
The amount of pieces?
The amount of pieces are,
Big or small?
okay, in this case they are what?
Small.
They're smaller. We cut them in half, right? We cut all of them in half so the pieces are smaller. They're, instead of 4ths, they're now in 8ths. That's smaller. Okay? And what else is different between 3/4 and 6/8? Look at the drawing. How many pieces are there now? 6 instead of 3. There's 3 pieces because 3/4 of the pizza's left, and then we cut all the slices that are left in half. And instead of now 3 pieces, there are 6 pieces. One for my 3 brothers, and my 2 sisters, and me. Except we all get a little piece instead of 3 of us going hungry.
Unless you steal it.
Okay? Yeah. I would have gotten beaten up by my older brother.
Yeah.
All right.
Same.
Look at this. Last chapter we talked about decimals, right? What's 0.5? 0.5. What is that as a fraction, Abby? That's 1/2, isn't it? How about 0.25? Daria? 1/4. 25 hundredths. Think about this. 25 hundredths is 1/4 of a what?
$1.
It's a whole, or 25 cents is 1/4 of $1, right? And 75 cents is 3/4 of a $1. Yes. Okay. How about 40 cents? How much is 40 cents of $1? How would you write that? How many cents are in $1?
100.
100, right? So what is that? That's in our fraction. Ethan.
There's 100 at the bottom. And
Good.
100 at the top.
100 cents, right?
And then 40 at the
And 40 at the top. How much of $1 is that? Noah?
Tenths.
4/10. It's 4/10 of a dollar.
Oh, 2/5.
It's also 2/5 of a dollar. Isn't it? Yeah, 4/10, 2/5. How did we get this? What did we do with these numbers? Emily? Simplified them. Yep, we do that in math. What operation can we do to get from 40 to 4? We're reducing the size of these by division. Dividing by what? From 40 to 4, divide by what?
2.
2.
Not to get there, but
Oh.
then, 10.
By 10. So by 10, whatever you do, if you divide the numerator by 10, you have to divide the denominator by 10. And then 4 and 10 have a common factor. What number goes into both 4 and 10?
40.
No, what goes into 4 and 10? You remember when we factored these? You guys, this is so cool. Last chapter we learned about factoring, right? Factoring 4. What makes 4? 2 and 2. What makes 10? 5 and 2. So we can factor both of these by 2. And reduce them to 2/5. Now, this is called simplest form. Okay? It's also called lowest terms. LT. Okay? Now, how do you know these are in lowest terms? What do you know about 2 and 5 from last chapter? Cool.
And they both don't have a common factor.
Okay, what are they called then? Well, if they don't have a common factor, good. But we know that they don't have a common factor because they're both prime. And if both numbers are prime and the top number does not go into the bottom number, then we know we have lowest terms. If both of them are prime, we know they're lowest terms. If the top number is prime, then we have to make sure it does not go into the bottom number. For example, if we have 5/15, is that lowest terms?
No.
But the 5 is prime. But it goes into 15. So we have to divide both numbers by 5. 1/3. Okay? Let's go back to our notes. A fraction is also what's called a ratio. And a ratio is a little bit different than the first type of fraction that we talked about. A ratio compares two amounts that are different. So, in our first example, 40 cents and 100 cents, we are talking about the same thing, aren't we? Cents and cents. Yep, cents and cents. So these are the same thing. They're the same subject. Okay? If we were talking about students in here, how many girls are there in this class? 9? 9 girl students. And if we were going to write the fraction of girl students, we would write 9 girl students. Yes. Out of 22 total. Always write it out of the total when you're writing a fraction. Okay? Fractions are the amount out of the total. Repeat that. Fractions are the amount out of the total. Okay? Now, if we were going to write the ratio of girl students to boy students. These are different subjects, and so we write them and write the number of girls over the number of boys, or using the dots. Girls to boys. So, if there are 22 students, how many, and there are 9 girls, how would we write it as a ratio? What would we put on the bottom? We wouldn't put 22, we'd put what?
13 boys.
13. This is the ratio of girls to boys. Okay, ratios are written this way also. 9 with a colon and then 13. The ratio of girls to boys in 6th grade is 9 to 13. Okay? Or the ratio of boys to girls is 13 to 9. Right. If you were given a ratio, how would you figure out the total? Brett.
You add it up.
Add the two numbers together. This is the total. Okay? Any questions on this? This is called, these are ratios. Ratios compare numbers of different amounts. This is last year's numbers for boys to girls. Okay?
It's almost exactly the same.
13 to 9 this year. Okay? Another thing about fractions. The top number, the numerator, is also the top number in division, the dividend. And the bottom number is the what?
Divisor.
It's the divisor. It's the number of the groups that you're making. Yes?
Does the ratio have to be in these two periods?
No. Nope. The ratio will be written depending on what you're talking about. If you want to talk about how many boys there are compared to how many girls there are, then you would write the boy number on top and the girl number on the bottom. Okay? Or you would write the boy number first, like we did here, with the colon between them, like this. Changing our numbers for this year, 13 and 9, right? And if you wanted to write it with a ratio like 13 to 9, you'd write it that way. Okay? Remember, ratios are different, compare different amounts. A fraction compares the amount to the what? What's on the bottom in a fraction? The divisor, the denominator, the total parts. Okay?
For the ratio, can you compare two numbers?
Just two in a ratio. Yep. Okay. Take a look at page 110. There are boxes marked A, B, and C. Okay? What is the ratio of red to yellow circles in C? What is the ratio of red to yellow? Roy? 2 to, you would say 2 to 3. Okay? There's 2 red, 2, 3, what? To what? 3 yellow. Okay, so the ratio of red to yellow is 2 to 3. You would, when you're reading it as a ratio, you say the number 2 between them. Okay? You say the number 2 between them. What's the ratio of yellow to red?
Wait.
Ethan? 3 to 2. What is the fraction of yellow?
3.
Out of? So say 3 out of 5.
3 out of 5.
Because there's 3 out of 5 total. What is the fraction of red, Daria? The fraction. 2/5, or 2 out of 5, right. Look at D, the box D. What is the fraction of shaded triangles, Abby? 2/6. Or if we reduce that, it would be 1/3. Yep. What is the ratio of shaded boxes, Liz? The ratio of shaded boxes, or not boxes, they're triangles, shaded pieces. 2 out of 6 would be a fraction. 2 to 4. Right. The ratio is 2 to 4. So there's 2 shaded and 4 that are what? Not shaded. Okay. How about triangles and squares? What is the fraction of green triangles, Ken? They're green, I think, right? They're greenish. What is the fraction of green triangles? 3 out of, nope. Of the total shapes, I should say. 3 out of 7. Yep. What is the ratio of squares to triangles? Lindsay. It's a little louder. 3 to 4. The ratio is 3 to 4. Okay? Do you understand the difference between a ratio and a fraction?
Yes.
Yep. What do you say in between the word in between a ratio? In between the two numbers you say
2.
2. Yes. What do you say if it's a fraction? You say 2 words if it's a fraction. Say it again. Out of. Out of. That means out of the total. Okay? Very good, 6th graders. Your assignment is